Hi, in this video we will look at how crude oil is formed and also at the structure and formula of the first four alkane molecules. Crude oil is a fossil fuel formed from the remains of marine organisms such as plankton, which died over 120 million years ago. When these tiny plankton died, their bodies sank to the sea floor where their remains were covered in sand, silt and other sediments. This prevented the normal processes of decay from occurring, since the bacteria which feeds on them had little or no oxygen. Instead, as they were buried, the temperature and pressure rose, and the remains of the plankton were slowly pressure cooked to form oil and gas. Over millions of years, these sediments slowly turned into rocks. Now, some of these rocks are porous, that is, sponge-like. These porous rocks will allow liquids and gases to soak into them and to pass through them. These porous rocks will allow the crude oil and natural gas to collect in them. Other layers of rocks which form are non-porous, and oil and gas will become trapped under these layers of non-porous rock, where it will be necessary to drill through these layers to get to the oil and gas. Crude oil, in its raw state out of the ground, is a black, thick, viscous liquid which consists of a mixture of thousands of different compounds. Many of the compounds found in crude oil are hydrocarbons, that is, molecules made up of only the elements hydrogen and carbon. Now, most of the hydrocarbons found in crude oil belong to an homologous series, a family of hydrocarbons called the alkanes. Now, all carbon atoms make 4 covalent bonds, and in an alkane molecule, the carbon atom makes 4 single covalent bonds. That is, we say they are saturated. 2 alkane molecules are shown on screen. A molecule of methane contains 1 single carbon atom bonded to 4 hydrogen atoms. Its molecular formula is therefore CH4, while a molecule of ethane contains 2 carbon atoms and 6 hydrogen atoms. Ethane's molecular formula is therefore C2H6. In alkanes, the carbon atoms are bonded to either hydrogen atoms or to other carbon atoms, while the hydrogen atoms are always bonded to carbon atoms. The alkanes are a family or homologous series of hydrocarbons where the carbon atoms present in these molecules will all make 4 single covalent bonds. As we have seen, the first member of the alkane homologous series is methane, which contains 1 carbon atom and 4 hydrogen atoms, as shown. The next member of the alkane homologous series is ethane, which contains 2 carbon atoms and 6 hydrogen atoms. Now, you may have noticed that in going from a methane molecule to an ethane molecule, you simply add a CH2 group. So to get the next member of the alkane series, propane, simply add another CH2 group to the ethane molecule as shown on screen. And to get the next member of the series, simply add another CH2 group to get the molecule butane C4H10. Now, in an homologous series is a family of molecules which show a gradual change in their physical properties, such as their melting and boiling points, and which also show similar chemical properties. All members of an homologous series share the same general formula. For example, the general formula for alkanes is CnH2n plus 2. This general formula will allow you to find the molecular formula for any alkane. For example, the next 2 members of the alkane homologous series are pentane and hexane. So what would the molecular formula for these 2 alkanes be? Well, for pentane, the next member of the series, it will have 5 carbon atoms. So in this case, n equals 5, so 2n plus 2 equals 12. So the molecular formula for pentane will be C5H12. And for hexane, which has got 6 carbon atoms, n will equal 6. So the number of hydrogens will be 2 times 6 plus 2, which equals 14. So hexane has the general formula C6H14.